Okay, so welcome to your tutorial for ChemDraw. This is the mechanism that you will be drawing to use in Lab Report 8, and you will also be submitting this as part of the requirements for Exercise 7. So just follow along on ChemDraw and you should be able to ace this one. Okay, so let's begin. You probably noticed that I've already got my document set up in a landscape orientation, meaning it's longer than it is tall. And that's because it's a lot easier for me to do this, to draw mechanisms in this way, because mechanisms tend to run long from left to right. Now, if you instead you have your document originally in the portrait settings, you simply go to the Page Setup from File menu and just check this radio button right here that says Landscape. So this will give you the portrait orientation and this will give you landscape orientation. So that gives me a little bit of extra room to work. Now let's get down to work. I need to draw my substrate for starters, which is t-butyl bromide. So I'm going to go to the single bond tool. I'm going to grab that tool by clicking on it with the left mouse button, and then come down here to my page and draw the bond simply by clicking and holding and then dragging the mouse in the direction I want that bond to point. So I want one bond to point straight over this way, I want another bond there, a third, and a fourth. So I've created the skeleton for my t-butyl bromide here. The next thing I want to do is place my bromine there. So I'm going to go up here and choose the text tool. And what that allows me to do is come back down, click on the end of a bond, and simply type the symbol for the element that I want. When I hit enter, it will attach that symbol to the end of that bond. So you can see here, if I select that atom and drag it, the bond goes right along with it. So I'm going to undo that with a Control-Z. That gives me my substrate. Next, I'll need my nucleophile. I need to put an alcohol here. So I'm going to go back to my solid bond tool and draw the framework for my alcohol. And I'm going to draw my alcohol vertical because it's going to make a nicer arrangement of everything in the future when I actually start putting in my arrows. That means that I would have an oxygen in the center here. I'm going to put my hydrogen up and my R group down here below. Okay, but we need to show lone pair electrons because this is going to be a nucleophilic attack that takes place. It would be nice to show the electron pair. So I'm going to go up here to my lone pair tool. Now if you don't see this tool up here, you can also come to the main toolbar and click and hold chemical symbols, and that will give you the option for the lone pair as well. And then if I click directly on the atom, ChemDraw will do its very best to place the lone pairs in the appropriate location. So there's two lone pairs on my oxygen. Now my next task is going to be to show the arrows that are corresponding to the leaving group departing, because remember this is SN1. So in order to do this, I'm going to use the arrows menu. And there's quite a few to choose from here. But I'm going to choose the curved arrow, which gives me the best representation of my leaving group departing. I'm going to go with this one up here because I think I can fit that in there nicely. And I'm going to start it from the middle of the bond that's breaking and drag, click and drag, and take that arrow over to the atom that's leaving, in this case the bromine. My next task is to place some arrows in there to show that I'm moving on to the next step. Now I can go back to my arrow menu again and notice that here we have equilibrium arrows we can choose from. This row here are all equal arrows with just different size arrowheads. Then down here we have the non-equal arrows. I'm going to go up here and just grab this one right here because I think it looks the nicest. I'm going to left click and drag to place my equilibrium arrows into the mechanism. Next I need to show my intermediates. Now one way that I can do this is to redraw everything, or another way to do it that's a little bit easier actually is to use the lasso tool to select my starting materials. Control-C, Control-V, and then just drag those starting materials over to where I'm going to be continuing my mechanism. Now it's as simple as altering those starting materials rather than redrawing the entire scheme. So here I can simply take my arrows away, break my bond, and I'll have my bromine as a bromide. So I need to go back to my text tool and change the bromine to bromide. Okay. And just to make things look pretty, I like to have my cations look like they are actually planar. So what I'm going to do here is make my t-butyl cation look a little bit more sp3. And it also needs a positive charge. So I'm simply going to use the text tool to create a plus, and I'm going to drag that plus right down here into place and release. And sometimes to make it look nicer, I like to increase font size a little bit on some of those charges. Maybe even make them bold so that they stand out a bit more. Okay, so now I have my intermediates, my bromide and my carbocation. It's time to add the arrow for my nucleophilic attack for my alcohol. So in this case, I'm going to go back to my arrow menu, and again, I'm going to choose a curved arrow that suits my needs. In this case, maybe a little bit shallower arrow than I had before. I'll start from the lone pair that's attacking, click and drag out to the center of my carbocation. Now you'll notice that it's snapping to certain distances. And if that becomes a problem for you, you can hold the Alt key, and that'll give you a smoother pull on your arrow, which allows you to put it just about anywhere that you like. Still trying to snap just a little bit there. Okay, that's a good arrow there. That goes directly from the attacking lone pair to the electrophilic site. Awesome. So now we have our intermediates and we have the electron flow in the second step of our reaction. Time to move on again. So I'll go back to my arrows. I'll grab another set of equilibrium arrows because this nucleophilic attack is reversible. And now I need to draw my next intermediate, but this time bonds are going to be moving and shifting a little bit more, so I'm going to just start from scratch and redraw. So in this case, I should have 1, 2, 3 methyl groups, an oxygen, which is then going to have its own R group, and it's also still going to have an acidic proton. So I need a skeleton that looks something like this. Then I'll place all the necessary atoms within it using the text tool. And keep in mind, of course, that there's a lone pair on the oxygen. And in fact, that oxygen is also positively charged. So I'll grab the text tool once more, add a plus symbol, and of course, as I like to do, increase the font size and make it bold a little bit. And I'll place that right over the oxygen. Okay, so I have a protonated alcohol with my new R group attached. What's next? Well, the next step, of course, is the final step, which is that alcohol needs to become deprotonated, or rather an ether, needs to become deprotonated because ethers are extremely acidic when protonated. So I'll go back to my mechanism arrows. I'm going to grab a nice, strongly curved arrow here, and I'm going to show the breaking of this bond by returning electrons back to the oxygen. Now, I'm not super happy with the way that that arrow is touching my plus symbol. So I'm going to use Control on my mouse wheel to zoom in a bit, grab that plus symbol and move it somewhere a little bit less obtrusive. Now I can go back to my arrow and I can continue manipulating my arrow by either rotating it, scaling it, or if I really wanted to, even redrawing it completely. Control and the mouse wheel brings me back to where I can see my entire document. Okay. So I've got the loss of a proton as my final step in my reaction. And what I'm going to do now is draw that last arrow and make this reaction irreversible using a single-headed arrow going in one direction. Now we're at a point where it's easy again for me to simply grab the lasso tool, copy my intermediates, Control-C, Control-V, and then modify those intermediates to complete my reaction. So here I can delete my charges and my arrows and also my bond. Now notice that ChemDraw is trying to correct for this and say, oh, you got a neutral hydrogen atom, you can't have that. So I have to go back here and tell it, no, that's actually an H+. And just to be thorough, I'm going to put my second pair of lone pair electrons in place. So this is a complete mechanism. From starting materials through all the intermediates, considering reversibility, showing all byproducts. This is an adequate mechanism to complete our Lab Report 8 and the requirements for Lab Report 7. So to complete the assignment, of course, you'll need to submit it. So you'll come down here to Save As, and be sure that you save as a ChemDraw or .cdx file initially. So I'll call this Assignment 7 and save it. This file can be reopened in ChemDraw and modified at a later time. But we also want to be sure that we can insert this into a Word document. Now this can be done in a number of ways. First, you could simply select everything, Control-C, and then go back over to a Word document and post by Control-V. Or you can save the file instead as a JPEG image. Now when you do this, it's going to prompt you, be careful, now you can't reopen this in ChemDraw, but that's alright because we want to post this into Microsoft Word. So I'm going to say that's okay, go ahead and save it as a JPEG. And of course, the final part of the assignment, you'll want to be sure that you open a new Word document. And as I mentioned previously, you can paste directly in. This document is pasted from ChemDraw. Or, if you prefer, you can simply insert a picture, browse down to your file, Google Drive for me. I placed it in Chem 117 Fall 2015 folder. There's my JPEG, assignment 7. I'll be inserting that. And again, I get the image inserted into my Word document. So you can see here that either one of these techniques will work. The advantage to the JPEG, of course, is that the image can be manipulated easily. But the advantage to posting the actual ChemDraw document in is that you can edit this later by double-clicking on it. See, it's given me the document back. And if I make changes here and save them, they'll also be saved in my Word document. So you have a couple of different options there on how to do that. Okay, so that's the complete procedure for creating your first mechanism in ChemDraw. Be sure that you submit both the CDX file and the Word document with the image or file inserted into it. And I will see you all for our experiment number 8 next week.